Good morning, 10th standard. So the last topic of your chapter 2 is on your numericals. So section C, numericals, here it is. So the first sum, they have asked us to calculate the potential energy provided with your kinetic energy. So always remember, when an object is at your free fall, you're going to drop an object and it is at free fall, at the starting point you will have only your potential energy, and at this point your kinetic energy will become 0. So once it reaches the ground surface, here your potential energy will become 0 and you will have only your kinetic energy. And we also know during this process the sum of potential energy and kinetic energy will be the same. So if I know the potential energy at this point, the same energy, the same value will be there for your kinetic energy. So for instance, think this. Let the potential energy at the starting be 5 joules. Therefore, the kinetic energy at the end of the journey will also be 5 joules. Similarly, if the kinetic energy is 5 joules here, what will be the potential energy over here? It is also 5 joules. Therefore, the potential energy at maximum height will be equal to the kinetic energy. Okay, this you have to remember whenever you are solving a sum. So using that principle, okay, we are just using the same principle in order to calculate our potential energy. So half mv square, because in this sum they have given only as the mass and the velocity. So you may wonder, just by using a mass and velocity, how can I find my potential energy? Because you have to invoke this formula. Okay, you have to invoke this formula. Therefore, half mass is 0.20 into 20 into 20, and you solve it, you will get your potential energy. And the same way applies for your second sum. The second sum also the same formula, the same method I am going to apply. Potential energy is equal to kinetic energy. So the same mgh is equal to half mv square. Apply the same one, half into the mass is 0.500 into 15 into 15, that is 15.625. Since the potential energy at the maximum height is equal to the kinetic energy at the ground, I am going to mention both of them are going to be the same. And next one, they are asking us to find the total energy. We all know total energy is equal to sum of potential energy plus kinetic energy. They are asking us to find the total energy halfway. So halfway means you have to divide it by 2. So if you divide it by 2, you will end up with your half total energy. Is it clear? So all these are simple concepts. Remember, the potential energy at the starting point and the kinetic energy at the ending point will be the same. Whereas the the kinetic energy at the starting point is 0, and potential energy at the ending point will be 0. Don't forget it. Okay, so if this is your starting point, that is your just dropping an object down. Okay, dropping the object down at maximum height. At maximum height you will have your potential energy. Kinetic energy will be 0. At the ground, potential energy will become 0, kinetic energy will be maximum, and this both will be the same. If it is going to be 10, this is also going to be 10. There is no change in it. Clearly understand this point. You will be using this for entire numericals in this section. And your fourth sum. So it states that a skier is going to it's just dropping down from 2 different heights. They're asking us to find the loss in potential energy. We have done certain sums like this in your previous videos. Whenever it drops from certain height, what will happen? Your potential energy will get, that will be reduced in potential energy. Now remember, you're going to have an object at a height of 5 meter and another object at a height of 3 meter. So who will have more potential energy here? The one which is at your 5 meters. So if I want to find the loss in it, I have to find the difference between this both potential energy. Therefore, mgh1, mgh2, one which is in 5 meter, one which is in 3 meter. So subtract this, you will get your loss in potential energy. The same formula I am going to apply here. Therefore, mgh1 minus mgh2, mg is common, I am going to take it outside, and inside the bracket you will have h1 minus h2. So 60 into 10 into 7.5 minus 1.5. 7.5 minus 1.5 is 6. Therefore, 60 into 10 into 6, this is 3600. 3600 can be written as 3.6 into 10 power 4. Yes or no? Okay, so can you understand? 3600 can be written as 60 into 10 into 60, it is 3000. You will be getting 36,000, which can be written as 3.6 into 10 power 4. So listen, 36 into 10 power 3. So in this 36 you have one 10. So if I take the 10 outside, I can write it as 3.6 into 10 into 10 power 3, which is 3.6 into 10 power 4. So that is how I write this final value. Therefore the loss in potential energy, this is equal to 3.6 into 10 power 4 joules. So this potential energy, so they are asking us to find the kinetic energy at the point B. Okay, so which is nothing but 75% of your potential loss in potential energy. So using that, so 75% means 75 by 100 into 3.6 into 10 power 4. You solve it, you will get your kinetic energy, and using this I'm going to find my velocity. Therefore kinetic energy is equal to half mv square. So what is your kinetic energy at this point? 2.7 into 10 power 4, and mass is 60. Therefore 1 by 2 into 60 into v square. So v square I needed to bring all these terms this side. So once it goes to this side, it will be in division. So therefore 2.7 into 10.4 divided by 30. So 2.7 can be written as 27 into 10 power 3. I'm just bringing 110 this side. Listen boys, 2.7 into 10 power 4. So can I write 2.7 into 10 into 10 power 3? I'm just bringing 110 outside. So multiply this both, you will get 27 into 10 power 3. So that is how I have written 27 into 10 power 3. Now cancel this, you will get 9. So below you will have 10 power 3 divided by 10. So if you cancel this, you will get 10 power 2. So 10 power 2 is nothing but 900. So 900 is equal to v square. Square root of v is 30. Therefore the velocity over here is 30 meter s minus 1. So by which we have completed this. I wanted you people to complete the remaining sums left out for you, and by tomorrow you'll be having test on your second chapter.